that. So here replace one tile ij by 16 tiles, but in the definition of this one tile, he uses the sets for left and right tiles, and upper and also. So he uses the set si. So he uses a lot of the neighboring sets. He uses.
Цветные не надо.
No, he replaces one tile with 4 tiles, and then he draws neighbor. Okay, sorry, yeah, I got it. Yeah. So the purple tiles is one tile from original reduction, and the white ones are neighboring is part from the neighboring sets after reduction, and it's part of the proof. Y is indexed by 4i and 4j. No, sorry, I'm not right. I don't think that purple is one tile. I think. No, I don't understand anything. Yeah. Yeah, I think the book is not helpful. It's probably a difficult question to invent, but yeah, I'm sorry, I actually solved myself before. But the fifth exercise is easy. Reduction from grid less than to the disk problem. So it's also in the book. It's just a picture. So what he says is that he creates a grid of disks and then moves the centers a little bit. So we have grid problem, and then he says, okay, let's make like centers that we will not use. And then the idea is to move the centers a little bit according to the numbers in the table. And so here are the centers. They are precisely on integer coordinates. So 1, 2, and so on till k. 1, 2 till k. And so then if we fit circle here, it will fit. Oh, my picture is not good, but you understand. So I fit circle here and here and here. and so on. So, but now I will have these little points. They move a little bit, and so here is like epsilon fraction, and so if I move here, so I will move coordinate here, and if I choose the point, so I can only the circle 1 and 2 will only be disjoint if if horizontal coordinate here has bigger shift in 2 than in 1, and the same for vertical shift. So, but there is a little bit of mistake. Maybe here the vertical coordinate goes up, and here the vertical coordinate here is down, and so then it increases the radius a little bit. But it's only a deviation in epsilon squared order. So if I have two circles, so here I have radius 1, but here I can, so if I put the other circle here at radius 1, so even though that this is less than 2, when I change the vertical coordinate, so if the distance between these two lines is less than 2, then I need to change the vertical coordinates a lot. So it can happen that this is 2 minus epsilon. So if this is 2 minus epsilon squared, then I go here epsilon down, then it works. So there is a little error. But the problem is that this goes like with the sinus of the thing. So if I go epsilon down, then this is only epsilon. So if this is 1, this is like 1 plus epsilon squared. It's proportional to epsilon squared. So if I change here a little bit, then it will still be okay. And so then if all the differences are more than epsilon squared here, then so we will choose small epsilon and choose as coordinates. And so the point ij. So in the set, for the set Sij, we will create the points I plus, so for xy, and Sij, we choose a point x and j plus epsilon y. So that's the idea. And we won't be able, since x and y are integer, and if epsilon is small enough, then if from the previous point we choose yij smaller, so if yij is smaller than, sorry, yij plus 1 smaller than yij, then the distance will be epsilon, but the sum of radius. So the distance between the cells will. Okay, you got what I want to say. And so because it's not a straight line, we get a little bit more. So if the points are here, the distance is more, but the extra distance is proportional to epsilon squared. So if we take epsilon polynomially small in the biggest number here, okay, it's not convincing. I should say it more clearly. So so I claim if epsilon is small enough, then our construction will imply that so let us give this a name. Let us call this Pi Ui. And so now we have to check that for 2 points, if so we have x I j bigger than one j and y but only if the distance between so that's what we want. But the problem is that this coordinate, so what is this distance? It's equal to, or let's say square distance bigger than 4. And so here we have pi j minus pi plus 1j squared plus q ij minus q I plus 1j squared. And so the problem is that this square also gives contribution. So we wanted, so what we have here is this 1 plus epsilon times x I j minus x I j plus 1